Hi, this is Jeremy Hunt, and this is my mood ring project for ELEC 327. Let's go ahead and go over here and program it with new code. So it's loading the program up. Let's go ahead and try that. Okay, and there we go. So, as you can see, this project uses a tricolor LED to display several different colors relative to a temperature that is read using this thermistor here. So if I pinch this, as you can see, the light eventually turns red as it warms up, and if I release it, it goes back cold again and turns blue. This process happens. There we go. This process happens by reading the color value, reading a thermistor value. So this thermistor right here changes its resistance based on the temperature that it is, and this resistance is read using a simple voltage divider using this fixed 10K resistor right here. And so this forms a voltage divider between a 2.5 volt reference voltage, which comes directly out of the MSP430. This 2.5 volt reference voltage is always the same. It's generated using an on-chip band gap reference generator and then buffered to the output. This gives us the ability to have changing input voltages. So right now VCC, the input voltage is 3.3 volts, but for the final project it will be running off a 3 volt battery, and that 3 volt battery will change depending on how charged the battery is. So this 2.5 volt reference voltage gives us a constant voltage to use for this project. This voltage divider then goes across here, and right here, this pin is read via the onboard 10-bit analog to digital converter on the MSP430. This analog to digital converter gives us a voltage gives us a reading of the voltage at this resistor divider point, which gives us a accurate measurement of the thermistor's resistance value. These two resistance, this value is used in the code. So I'll go back over here. This value is used to determine the color of the light. So right here we have defined a minimum and maximum value that the analog digital converter is expected to read. One of the maximum value is the value expected at about room temperature, and the minimum value is the value expected at around skin temperature. Between these two values, the output is calculated using just a linear interpolation, and so that is done down here. The reading takes in this value and then linearly interpolates it to determine the PWM values for the red and blue channels of the tricolor LED. This interpolated value is then used to drive the tricolor LED. The PWM for that LED is generated using the MSP430's timer A1, and then that clock is generated via the onboard very low voltage oscillator. This clock runs at about 12 kilohertz, and by counting several periods of this clock and then tying that to a counter in the MSP430, we can generate PWM signals. The duty cycle the duty cycle is what is actually controlled by the temperature, and the period is constant. It's currently set to about 60 hertz, which gives us a nice smooth color. Any lower and it would start to look a little choppy. Is because that 60 Hertz was chosen because that's about the flicker fusion rate for humans. The ADC is triggered via another timer, timer 0, which is also driven from that very low frequency oscillator. And that is automatically triggered. The ADC can actually be triggered automatically from that output of a timer. So there is actually only one interrupt, and that interrupt happens when the analog-digital converter finishes its operation. And during that interrupt, the ADC is reset. The value is read from the last conversion. The colors for the PWMs are calculated and set, and the ADC is set up again so that the next time the timer triggers it, it runs. No code is generally running while the chip is on. The only code that runs is that interrupt service routine when the analog to digital converter finishes. Everything else happens automatically, and the chip is actually in low power mode 3, which turns off nearly everything on the chip. So it's a very low power operation. Without the LED, the chip only pulls around 200, maybe 250 microamps. So it's actually quite low power. So there is my project. Thank you for watching.